Hello everyone, I am here to present a seminar on the topic cloud applications. Social networking. Social networking applications have grown considerably in the last few years to become the most active sites on the web. The possibility of continuously adding capacity while systems are running is the most attractive features of social networks, which constantly increase their use base. So let's take an example of social networking application. Facebook. Facebook is probably the most evident and interesting environment in social networking. It has more than 800 million users. It has become one of the largest websites in the world. The development of services is facilitated by a set of internally developed tools. One of the core elements is thrift. This is a collection of abstractions, which is nothing but a language bindings that allow cross language development. Thrift allows services developed in different languages to communicate and exchange data. Next is media applications. Media applications are a considerable advantage from leveraging cloud computing technologies. In particular, video processing operations such as encoding, transcoding, composition, and rendering are good candidates for a cloud based environment. Animoto, the most popular example of media applications on the cloud. The website provides users with a very straightforward interface for quickly creating videos out of images, music, and video fragments submitted by users. Users select a specific theme for a video, upload the photos and videos, and order them in a sequence they want it to appear. Selecting the song for the music and rendering the video, the process is executed in the background and the user is notified via email once the video is rendered. This is the Animator reference architecture. Let's go into deep. The core function is implemented on top of the Amazon Web Services infrastructure. In particular, it uses Amazon EC2 for the web front end and worker nodes such as Amazon S3 for storage of pictures, music, videos, and Amazon SQS for connecting all the components. The system's auto scaling capabilities are managed by RightScale. Front-end nodes collect the components required to make the video and store them in S3. Once the storyboard of the video is completed, a video rendering request is entered into a SQS queue. Worker nodes pick up rendering requests and perform the rendering. When the process is completed, another message is entered into a different SQS queue and another request is served. This process happens with every individual user. Next, Maya rendering with Aneka. A private cloud solution for rendering train designs has been implemented by the engineering department of GoFront Group, a division of China Southern Railway. The department is responsible for designing models of high-speed electric locomotives, metro cars, urban transportation vehicles, and motor trains. The design process for prototypes requires high quality three dimensional images. The analysis of these images can help engineers identify problems and correct their design. Three dimensional rendering tasks take considerable amounts of time, especially in the case of huge numbers of frames, but it is critical for the department to reduce the time spent in these iterations. This goal has been achieved by leveraging cloud computing technologies, which turned the network of desktops in the department into a desktop cloud managed by Aneka. So, next we will see about video encoding and transcoding. Video encoding and transcoding are operations that are greatly benefit from using cloud technologies. They are computationally intensive and potentially require considerable amounts of storage. Moreover, with the continuous improvement of mobile devices as well as the diffusion of the internet, requests for video content have significantly increased. Encoding.com is a software solution that offers video transcoding services on demand and leverages cloud technology to provide both the horsepower required for video conversion and the storage for staging videos. The service integrates with both AWS technologies such as EC2, S3, and CloudFront. Along with that, Rackspace, cloud servers, cloud files, and Limelight CDN access. Users can access the services through a variety of interface, such as the encoding.com website. It can be either web service XML APIs or desktop applications. To use the service, users have to specify the location of the video to transcode. The destination format and the target location of the video. Encoding.com also offers other video editing operations such as the insertion of thumbnails, watermarks, or logos. Moreover, it extends its capabilities to audio and image conversion. The service provides various pricing options: monthly fee or pay as you go, and special prices for high volumes. Encoding.com now has more than 2000 customers and has already processed more than 10 million videos. Lastly, multiplayer online gaming. Online multiplayer gaming attracts millions of gamers around the world who share a common experience by playing together in a virtual environment that extends beyond the boundaries of a normal LAN. This is a scalable processing of logs for network games. Game log processing is also utilized to build statistics on players and rank them. These features constitute the additional value of online gaming portals that attract more and more gamers. The processing of game logs is a potentially compute intensive operation that strongly depends on the number of players online and the number of games monitored. Moreover, gaming portals are web applications and therefore might suffer from the spiky behavior of users that can randomly generate large amounts of volatile workloads that do not justify capacity planning. The use of the cloud computing technologies can provide the required elasticity of seamlessly processing these workloads and scale as required when the number of users increases. Finally, to conclude my seminar, all these new opportunities have transformed the way we use these applications on a daily basis, but they also introduced new challenges for developers who have to rethink their designs to better benefit from classic scalability, on demand resource provisioning, and ubiquity. These are key features of cloud technology that make it an attractive solution in several domains.